Well, hello, Internet. My name is Somy Kamble, and today we would be learning what is deep learning and how to implement a very basic example of deep learning uh, with a pre-built, you can say database or you can say data. And we would learn about classification example, and in other terms, we would call it as a logistic regression example. You can say it's a very basic logistic regression example. So if you don't know how to install deep learning packages such as Keras, TensorFlow, so I will let you know that. The very first thing what I encourage you is to first download Conda software from the internet and configure with the help of Python accordingly. Then what we have to do is we have to install a package named Keras. All right. Once you have installed that package, all you have to do is run this command as install Keras, and it will take care of itself. So you don't have to install anything else on top of it. Yeah, if you want to specify a specific version of TensorFlow, suppose my TensorFlow is running on the latest 2.0.0. So if you want, you can specify that as well. All right, so let's get everything in action and let's begin. So there are two libraries. What we would require first is ML bench. Next is the Keras. Okay, moving on to before moving on to the coding part, or you can say the example, let me give you a very brief example, or you can say a very basic example. What is a deep learning? So a deep learning is a very broad, you can say, is an application of machine learning, which constitutes of working of different neural networks in a connected fashion, and which would give you a predefined output, or you can say it can work on supervised learning, it would work on unsupervised learning as well, and it is you can say the talk of the town, and it's a fairly a very buzzing word in the data science technology. Okay, saying having said all that, uh, let me give you an example. Suppose if we let's take a machine learning example. If we feed a machine learning algorithm with few images of cats, few images of dogs, all right, or suppose if we uh, feed a machine learning example, few images of donkey, few images of horses, all right. So it would classify both the horses and the donkeys as well, until unless we feed the perfect image. Suppose if we give an image of a mule, which is a cross between a horse and a donkey, then I don't think a machine learning uh, algorithm would yield us good results. But what happens at the deep learning is that it divides every problem in a very minute level. It divides the problem on its pixel level, then it calibrates the neurons, perceptrons, and on the activation level, and then actually for that we use CNN, that's a convoluted neural networks, which is an application of you can say deep learning. So it would be able to classify whether based on the features of the mule. Suppose if it has long limbs and mostly inclined towards the horse features, then it would completely classify it as horse. Or let's take a cat and dog example. Suppose if we feed a machine learning example with the photographs of Doberman, and we trained our model with a specific breed of cat or a specific breed of dog. So as long as when you feed those particular breed images to a machine learning algorithm, a machine learning would be working fine. However, when you feed an another breed of dog's image or an another breed of cat's image, then it won't be able to yield perfect results. Whereas compared to deep learning, it has got its own feature extraction things that you've trained or you make a model of deep learning neurons or convoluted neural networks, and it would take care of itself. That means it would extract the features based on the images, and then it would have few things that yes, this is the parameter that I should classify this as dog. Even if we give it a different breed's image of dog, it would be able to classify. Okay, having said that, if you have any doubts, you can ping me, or you can contact me via comment section below. Okay, let's get started. All right, I guess this is much better. So we will today detect how to apply logistic regression on a data set of breast cancer. All right, so there is a data set named as breast cancer, which is a part of ML bench. So if we look over here, so you get a data set, right? So you have got the class such as malignant, and it's a different class as benign cancer. So these are two types of cancer, and we have to classify that which kind of cancer the person is going through. All right, so you have to be very careful while dealing with the Keras package or any deep learning. So let's see what our Keras package has packed up with us. To to see our Keras package, or you can say to see the details of the Keras package or the installation of Keras package, what you can do is you can just type reticulate package or simply py slash config. Alright, so it would give us the Python configuration, which is the courtesy of reticulate package. Right, so over here, let me pull this thing out. Right, so over here, what it says that we have got our conda environments over here, the version of Anaconda. Then we know where our TensorFlow is being stored. So this is where it's pulling the TensorFlow. All right. So if you want to see the installation of TensorFlow, so we would type TensorFlow and ty. Let's tf. Sorry, config. So as you can see, the version what I'm running is 2.0.0. Right. So this is how you can check the configuration of your Python, the configuration of Anaconda, or the backend what your Keras package is running on. So there are different ways. Right. So let's begin with the coding. So there is a package what we have known. There is a data set as breast cancer. We already had a look. We had a glance on this data package. So the first thing first, what is that we would store that data set in a variable name as, or you can say a data frame name as data2. Again, it has got 600 now, 7 approx 700 observation 11 variables. All right. Next, we would clean the data. So over here, what we would do is that we would omit any NA, or you can say any missing values. So we have done this. And also what we have learned is that whatever we do, but ID is just an ID given to a patient, and I don't think it would help us in determination of cancer or determination of anything. We'll look in the data set. Right, so what we would do is we would remove that column. To remove that, what we would do is type data 2, and we have removed the column. The next important thing you have to always remember is that always remember that TensorFlow only understands the numeric language. All right, no non-numeric things are allowed in the TensorFlow. If we have a look at our data to data frame, so what we can see over here is that this class, or you can say the end row, is made up of non-numeric. All right, so what we would do is that we would run a for loop wherein we would convert every column to a numeric form. For that, what we would do is we would run a for loop for I in 1 to n call. N calls states the number of column in your data frame 2. If we run this, we would give us 10 number of columns. So this is the number of variables or the number of columns. So let's go ahead with it and run. Okay, so what I've said is that first convert every character into factor, and those factor would be converted into a numeric form. All right, suppose let's take an example. If I type 2 and I convert, so if I type 10, all right, so the 10th column is of character format. All right, and we would convert it into the factor, so it would give that it has two factors. All right, so let's see what it gives. Okay, so it has given us levels as benign and malignant. I'm sorry for the pronunciation since I'm not from the medical background. So let's see the levels. If you want to see the level, you would copy this thing, type in levels. So it has got two levels. One is benign and another is malignant. So what I would do is that I would convert these two factors into the numeric form, wherein my data set, every column has been converted into a numeric format. Uh, Already most of the columns were in numeric format, so uh, actually what we wanted to do is we wanted to just convert this thing into the numeric structure, that is ones and twos. So in for general purpose, whenever you are dealing with any character or a categorical variable, so you have to run this for loop. So this is for the general purpose. Next, what you have to remember is TensorFlow. So if we break the word, it is made of two words. One is tensor, another is flow. So tensor deals with, you know, tensor means you can say the computation of numbers in a matrix format. This is what you should think, or you should keep in mind, that one thing, that TensorFlow always entertains numeric data. There is no character, no categorical variable entertained by TensorFlow. Another, mostly it deals with the matrix formats of the data. So since we have our dataset already been converted into the numeric format, so it's pretty much easy for us that we could convert it into a matrix format. So the command to convert data to data frame into as matrix is as.matrix. All right, here we go. So if we look into the dimension of data2, so we have got 683 rows by 10 columns. So our data 3 has been converted to a matrix format, which is the basic requirement for the TensorFlow and the Keras package. All right. So now what we have to do is that we have to split our data frame into two parts, that is training and the testing data set. For this we would use a sample command wherein we have to specify the number of categories or the number of partition what we wanted to do. So I've done two partition, then n row states for the number of rows. Another you have to say the probability. Suppose I want to divide my data set into 80 to 20%. That means 80% would be my trained data set, 20% would be my testing data set, and replace it by 2. So let's run this command. Next, what I wanted to do is that I wanted to specify what would be my trained data set and what would be my test data set. All right. So over here, I would just inform those rows who has a split as equal to 1 would be assigned as a training data set, and those rows who have a split equal to will have will be assigned as testing data set. Okay. Next what we have to do is that we have to take our train x, that is the input that would be given to our deep learning model, and we have to take the labels out of it on which our this model will be trained. Okay, so over here, if we observe our data set, that this is the dependent variable for which we have to make the calculation. Other than this, other than class, all are the independent variables, what we speak in more layman terms, are the machine learning language term. So again, from column 1 till column 9, we have got a input, or you can say the independent variable, and class is the dependent variable, or we can say these are the labels for our deep learning module. So we would just take those columns for 1 from 1 to 9, and we would assign train y as numeric as factor. That again, just for my, you can say, just for a double check, I've converted numeric as factor. If we don't do it, it's no harm, but it's great, or it's better you do it twice. All right. Okay, so we have got train y. Okay, so we have to subtract 1 from it. So what this would do is that if we don't do it, then this is one hot encoding. That means it would convert your train labels into the, it would convert the last column into the train labels. If we do this, train y equals to train y minus 1, and you have to, so a moment, let me put this thing up. All right, so this is train y to categorical. That means I have converted my labels to the category. I've done a one hot encoding for my train labels. So as you can see that it has divided the test data, the malignant and malignant, whatever is the uh, other form of cancer, into two types, that either it's one or either it's zero. Same goes for the test data set. So our input to the model would be 1 to 9. Then again, for just for double check, this is test y equals to test y minus 1 and to the categorical. Okay, now this is the most important part of our deep learning module. So over here we have to first define the model, and this is the sequential model. All right, so there are two types of model. One is sequential model, and another is the uh, feed forward model, wherein you can give the input to a model on the code. So this is first you so the just remember that the Keras sequential model is a predefined set of model. uh, that's all for the time being. I would make another train, you can say, a video for explaining what is a sequential model and what is feed-forward model, what is CN, what are RN, and all right. So Keras allows the pipe operator to work over here. We would use the command layer tens. Okay, and the units 512 means that we would be using 512 neurons. All right, so it's always better to have 2 to the power 9. So it is 512. Since our input, that means our input would be the number of independent variables, that is from 1 till 9. All right, this would be the input to the deep learning module. And the activation function what I've used over here is the ReLU. All right, so what is ReLU? So in very basic terms, so ReLU is the kind of activation functions that it would give you either 1 or either 0. 1 means that the neuron would be fired. 0 means the neuron would not be fired, so that it would be wired together. So always remember, there is one thing: those neurons, those fire together, wire together. Having said that, this is how the ReLU function works. That is, there is a kind of threshold made, or you can say, suppose if my uh, neuron fire more than 5%, or if they fire more than 50%, or any kind of value, so then and only then the neurons would be activated and the result would be forwarded to the next neuron. So we have used first is the input layer. This is the input layer. Over here the input shape is 9, the activation is ReLU function, and the units or the number of neurons what we are using for the input function is 512. And always remember that it's most probably the best to keep to the power of 2 and 2th power of the input shape what we will be giving. Next we have used two hidden layers. Right, two hidden layers. For that we have utilized 10 neurons each, and the activation function is ReLU. Next is the output layer. So the output layer has two units, because we are either it's a benign cancer or it's a malignant cancer. All right, and the function what we are using is the sigmoid function over here, since we are dealing with you can say categorical categorical classification. That's the reason we have used this activation function. Either it would be 1 or either it's be 2. That's the reason you have to use sigmoid as the activation layer of the output layer. So having said that, we would create our model over here. So our model is been created. Now always remember that these all things should be attached to each other via pipe symbol. Next we have to compile our model because behind if we don't compile, so the model would be of no use. Every compilation function has three steps. That's loss, the optimizer, and the matrix. Over here we have used loss as the binary cross entropy, and the optimizer is the Adam optimizer, and the matrix we would be using as the accuracy. So we would compile it. Okay, so let's see the model summary over here. So we have got 10,382 parameters, or you can say the features on which our model would be trained. So it's always to have a good thing that you double check that is the train X converted into a matrix or not. So you have converted your train X, that would be the input on which your model would be trained, the deep learning module would be trained. You have to check the class. Next, over here we would be using fit function, which would be in conjunction with our model. There is a forward pipe operator over here. The inputs would be given as fit. Then the train x is the number of the matrix format of the independent variables, and y is the train variable, the train labels. What we have done is that over here we have converted those train labels to a categorical function with the help of one hot encoding, and we state the epochs. So epochs, you can say, are the number of iterations that run on these number of parameters. And then sorry and then what we have done is that we have divided our train data into a validation split of 0.2. That means out of this train x, zero point 0.8 would be used for training, that's 80% would be used for training, and 20% would be used for validation. So always remember, you have to, it's better if you have this validation split as 0.2. Next we have to run this command. So once you run this command, all you have to do is sit back and you have to on your view. So let it work. Actually this is okay. So now what you can see, this is the loss and this is the validation loss. So the training loss is at 50%, whereas the validation loss is at 2.5%. This is the accuracy. Accuracy is the validation accuracy, and this is the testing accuracy. So you can see our model is so perfect that the validation accuracy is running at par. That means it's running pretty well. And then you can see the validation loss. So since there is quite a bit of time over here, so I would pause the video and come back to you when this 50 epochs are run. Okay guys, catch you up. Okay, guys, we are done with the 50 box. So over here we are represented with two graphs. One is for the loss and other is the accuracy. So always remember that the loss should be as minimum as possible. And if we look at the last epoch, so the loss over here is 0.1128 and the accuracy was 95. And over here, if we look at the validation loss, it was just 3%, and the validation accuracy was 99%, and which is at the last epoch. So always remember, guys, that this graph should be touching towards the high end. Since this is loss, so we have to minimize the loss and we have to increase the accuracy. So let's plot the history. So if we could click on plot, so this is a history. So over here, the blue line is for validation and the pink line is for the training set. All right. So to check the score, we would use an evaluate command, which is from the Keras package. We would give the input as test x, and to validate it or to validate it, we would use test y. Since we have converted them to the one the test label as well, so with the help of one hot encoding. So to check these loss and accuracy, what we would do is that we would use score dollar loss for loss and score dollar ACC for the accuracy. So over here you can see the accuracy is 97% and the loss is just 12%. Again, further, if you want to predict the classes, you can predict it by giving the matrix of the independent variable with conjunction with our model, just like the logistic regression. So we would use, if we don't use even the library carrier, we would be able to generate a table. So over here we can see that when a model says that the person is malignant cancer or whatever might be the category, so it is 86. Even the test results are 86. However, there were two instances when our model said that it's a malignant or benign cancer, but it was a malignant cancer. Where there were just two instances. Going on for the next next category, there was just one instance where our model said that it's a malignant cancer, whereas you can see the test data set shows that it was a benign cancer, whereas 48 were the number of instances where our model thought it's malignant cancer. Even the test result shows the same. To calculate the accuracy, we will generate a confusion matrix with the help of Keras package. So over here, since we can see the accuracy is 97.81%. So this is the very basic of how to detect which cancer it is, or you can see the very basic of deep learning module. So to increase the accuracy, you can tweak around the number of neurons. Do not tweak with the input shape, because this is the input what we will be giving to the Keras package. Oh, sorry, to our deep learning module. So you can tweak the number of hidden layers and then recompile it. You can tweak the number of epochs and generate good results. And the best thing what I would encourage you to do is just normalize the data and see. the results accordingly. So one more thing, guys, there is a link in description below wherein you can see the GitHub repository of the code, and as well I've uploaded the code on rpubs, so you can view the compiled version of the same. And also if you have any doubts, you can reach me with the Skype information, or you can share your comments. What should be the next topic? What should I make? Just let me know in advance. And also, if you can, just help me on Patreon, so that it would be really helpful for me, that I could give you more such contents. If you like it, please hit like, share, subscribe to my channel. Thank you guys, and have a great day. Bye bye.